Okay, a couple of examples. I'm hoping this is going to work. It's the biggest I could get this print, so if you really can't see it, you have to tell me and I'll try and do something else next time. So we've got a communication network. Messages are received one at a time. Check for errors. 6% of messages have an error in them. Errors in one message are independent of errors in any other message. And we want to find, first of all, the probability that the first message which contains an error is the fifth message to be checked. So X is geometric. And the probability is 0.06. So that's your first success, in inverted commas, because it's an error this time. And the probability that X is equal to 5 will be 1 minus 0.06, 0.94 to the power 4 times by 0.06. So 0.0468. Second part, find the mean number of messages before the first that contains an error is found. So the mean is the same as the expectation. You should be happy with that. I did some work on that before. And the expectation of a geometric distribution is 1 over p. So it's 1 over 0.06. And you get 16.7 messages. So 3 sig fig, blah, so it's a technical term, so it can have decimals. Next bit, we want to find a probability that there are no errors in the first 10 messages. That means your first success will come after the 10th. So it's the same as the probability X is bigger than 10. The probability you have no successes in the first 10 is 0.94 to the power 10. So that should feel okay. 0.539. And then part 4, the most likely number of messages to be checked to find the first that contains an error. This always feels slightly counterintuitive, but the most likely in any geometric distribution is always 1. So it's an individual probability. That is the one with the highest probability. It doesn't mean that the sum of the rest is going to be smaller than that, but the most likely number is always 1, but the expected number is 16.7. So it feels a little bit counterintuitive, but because p is close to 0, you're actually decreasing very, very slowly. So if you were to draw a sketch of that geometric distribution, it's going to, you're only timesing by 0.94 each time. So it's going to be coming down very slowly. So if you sum these, you're going to get something a lot bigger than the probability X equals 1. But it's an individual probability. It's the most likely, and it will be for any geometric distribution. So that's that. That's actually in your textbook if you're finding it difficult to read. But I'll try printing it out. I just didn't want to have to write out loads of examples. I wasn't quite sure how else to do that. On some postcards if you have a better idea. Right, example 9.3. X is geometric P, and we know the variance of X is 20. So variance of X is 20. First thing is to find P. So variance of X is 1 minus P over P squared. which is 20, and then we end up with a quadratic in P. And so you get 20p squared plus p minus 1. And then you can just chuck that into a calculator. That gives you p equals 0.2 or p equals negative 0.25. That's obviously not possible because p is going to be between 0 and 1. Try and remember to underline your answers, or at least make your answers clear. I haven't nagged you about that as well. Probability x equals 7, so you get your first success on the 7th trial is going to be 1 minus p, which is 0.8 to the power 6 times 0.2. That's kind of your tree diagram stuff really in terms of logics. It's nothing to worry about too much. 0.0524. And then we did do this, but I thought it's probably worth seeing again. So the probability x is 10, given that x is more than 7. So that's the same as the probability that x is equal to 3, because the geometric distribution has no memory. So the fact that you've not got a success 7 times, the probability you get your first success on the 10th will still, it's the third one along after 7. So that's 0.8 squared times 0.2, which is 0.128. So bringing in the expectation variance, it doesn't make the questions particularly more difficult. They're in the book and it's just another string to your bow really. And if you square root the variance, remember you will get the standard deviation. So if you're asked for the standard deviation, just to remind you, that's equal to the square root of the variance, and the mean and the expectation are the same thing.